Hello, I'm Max Guenther. I work for ESA as Project Scientist and Mission Representative for the Cheops mission. As a scientist, I use software to help analyze complex data. I'm going to show you how to use a program that will help you in your investigation. Exoplanets are difficult to detect since their signal is much smaller than the host stars. Exoplanet scientists use satellites like Cheops to collect data in order to find and study exoplanets. The raw data from the satellite can look very complex, so how do we identify the exoplanet signal hidden in this data? This is where mathematical models come in. We use these models to find the exoplanets. Let's find out how you can use allesfitter in the classroom to find exoplanets in the data received by Cheops. Here's how it works. Open hackanexoplanet.esa.int/allesfitter in a browser. When allesfitter first launches, it opens as a Binder project instance. It may take some time for the software to load, but if after 5 minutes or so the software has not yet loaded, try to open it again using a different browser or device. Once the software has loaded, a screen of code will appear. Click the Fast Forward button on the toolbar at the top of the screen in order to hide all that code and load the Hack an Exoplanet mode. Once the Fast Forward button is clicked, a pop-up warning will appear asking to restart the kernel and rerun the whole notebook. To load the software, be sure to click the red button to restart and run all cells. Now the tool is ready to start your investigation. Select your exoplanet. To do so, use the drop-down menu. Once an exoplanet has been selected, a light curve of the data collected from the exoplanet during the observation of the transit should appear at the bottom of the screen. The blue dots represent the individual data points during the observation, and the gray line represents the current model fit using the inputted parameters. The value for the different parameters can be adjusted by sliding the sliders left and right to increase or decrease the value. The values that will need to be adjusted are the radius of the exoplanet in units of Earth radii, the radius of the exoplanet's host star in units of solar radii, and the mid-transit time in units of days. You can observe how each parameter changes the fit of the model. Once the parameter values that provide a good fit to the data have been found, click the Investigate button that appears. The software will now fit the model to the data to find the best fit. This can take a few minutes to complete, and the progress can be tracked as the software runs. The model fit is created using a Markov chain Monte Carlo statistical method. Now, what does a Markov chain Monte Carlo simulation do? Well, imagine you're blindfolded at your birthday party and spun around by your friends, and your goal is to find a piñata or any hidden object. Your friends will tell you warm, warm when you get closer to that piñata or object, or cold, cold when you get further away. And that is pretty much the principle of a Markov chain Monte Carlo. Once the results are ready, a message will display and two new tabs will appear next to the light curve tab, histograms and table. You can now analyze the results to determine certain characteristics of the exoplanets. To download the results you have collected, go to the relevant tab for the data you wish to download, light curve, histogram or table. Under the displayed data, you can find a download link. Click the link and the results will open in a new tab. Don't forget to download and save the results. Now it's your turn to become an exoplanet scientist. Once you have your best fit, continue your investigation in the next video and become an exoplanet scientist like me.